The amount of heat required per unit of mass to change its temperature by 1 degree is called the specific heat capacity. That's the technical
Mm-hmm.
definition, but let's try to understand this with a practical example. Imagine going to the beach on a hot summer afternoon. The sand feels uncomfortably hot under your bare feet. To cool off, you dip your feet in the oncoming waves. Have you ever wondered why the sand is so hot while the water is cool, even though they are both being exposed to the same amount of heat from the sun? When heat is applied to an object, its temperature increases, and when heat is reduced, its temperature decreases accordingly. Some materials resist the change in their temperature more than others. In other words, the temperature of some materials will increase quickly when you supply them with heat. In contrast, some materials will take longer and require more heat to increase their temperature by the same amount. Specific heat capacity measures how much heat energy is needed to raise the temperature of a given substance. The specific heat of a substance is also influenced by its mass. An object with greater mass requires more heat to increase its temperature than an object with less mass. Conversely, the temperature of an object with less mass will increase more when the same amount of heat is applied. Mathematically, this relationship between heat, temperature, and mass is represented as shown, where C represents heat capacity, Q is the heat energy absorbed or released in joules, M is the mass of the object, and delta T is the change in temperature in degrees Celsius. Have you ever noticed that when you boil water in a metal pot, the pot heats up very quickly, even when the water doesn't seem hot or boiling? This happens because of the different heat capacities of the two materials. Metals generally have a low specific heat capacity, which means they don't need much energy to get hot. On the other hand, water takes longer to heat up because it has a higher specific heat capacity compared to the metal the pot is made of. Specifically, the specific heat capacity of water in liquid form is 4.184 joules per gram degrees Celsius, while for aluminum, it's 0.9 joule per gram degrees Celsius. For copper, it's even lower, at only 0.385 joules per gram degrees Celsius, so a copper pot will get hot more quickly than an aluminum pot. Understanding the concept of specific heat capacity provides insights into the relationship between heat and temperature for objects not just on our planet, but across the universe. For example, astronomers make educated guesses about the surface and composition of celestial bodies by observing how they respond to heat from the sun. The study of heat capacity is also vital in studying weather patterns and predictions. Material and structural engineers use the concept of specific heat to design heating and cooling systems in buildings to effectively regulate their temperature, making this concept relevant and applicable in our daily lives. Without even realizing it, we all have a basic understanding of specific heat, considering that we apply the knowledge of this concept in everyday activities. From bathing and cooking to washing the clothes and dishes, we use the principles of specific heat capacity all the time, making this scientific concept feel familiar and relatable. The beauty of the world of physics is that concepts and ideas we see in action in our everyday lives are fundamentally connected to unlocking the mysteries of the universe. Specific heat capacity is just one of those eye-opening ideas.